Hi everybody. So today we're going to look at creating desk 6 feet apart in Dynamo. This was a script I built 4 or 5 months ago, kind of at the beginning of all this COVID-19 stuff. And uh, it was a fun script. I don't think we actually used it. Just because it wasn't necessary for the project. We could figure out, just based off of the area of the room, you know, the number of desks that are probably going to be in that space. Um, but you could take this script and probably apply it to many other things. There may be also a better way to look at this script or create the same thing. I'm always open for suggestions, or if you just want to comment and mention those things, feel free to do so. But I'm going to kind of show you, we're going to stick to PowerPoint, and I'm going to kind of go through each thing, or at least each group within the script, and we'll talk about it. And also, all these scripts that I make, that goes for anything. You can find the documents, the files, in the OneDrive link in the description. So you could go grab this script and use it yourself on a project. And that goes for any other script that I've created. You can grab them and go ahead and start playing with them. Because I feel like that's the best way to learn. Just grab it, play with it, and see the flow of information. And just see how it connects and how I'm leveraging levels and other things. So anyways, let's get started. We're just going to look at the kind of the workspace real quick, and just kind of give you an idea of what we're going to look at individually. So this is the script, and that we've got some groups in there. And you can kind of see what's happening in the background. There's some walls and then some boxes within those walls, and you can see there's multiple groups of them. And so what we're gonna do is pretty much place desks within spaces, so within rooms, 6 feet apart, and that's kind of it. And we're gonna try to optimize how many are in there, and then so I'll just break this down group by group. Dynamo group. So this is what it looks like when it runs and it actually places the desk. You can see this back wall, it didn't place any desk, because if it were to place desk, it would actually be inside the wall, and if it were to move the desk forward, then it would be too close to the other person, and they would be within that 6 feet limit. And here you could also, there's an offset that we can put so that the to account for the students sitting in the desk, we can give it an offset and stuff like that. So those things are inside the script, so that to account for the chair and where the student's going to sit, you can give an offset so that they're not sitting inside the wall. This is what it looks like from Dynamo's perspective. Now there's a few things that are the preview is turned off. But if you do turn that on, you can see everything kind of in there. But this is kind of an overview of kind of what's in there, or just a brief look. So you can see there's some geometry, some walls that we're gonna clash against, just to see if those elements are in the wall. Then we can remove them and say, hey, we don't want to place a desk there. And then you can see the points and stuff that we're gonna leverage to actually place the desk. So let's go ahead and kind of look at this script group by group. I tried to add as much information as I could. I think along with the notes, and so the groups, the notes, and the nodes themselves that are themselves are pretty descriptive. I think I think you can follow this, even if you take this script and mess with it yourself without watching this, I think it shouldn't be that hard to follow along and see how the information is flowing from start to finish. So these are primarily what we're going to look at, are these groups. And then the rest of it, we'll just ignore. Some of these are just watch nodes. This last little bit here actually places the desk. There's nothing wild happening there, but I didn't think there was a reason to highlight that, but that's what that's doing at the end of the script. So we'll start with just getting the rooms. Now, I do want to mention this one. So this is just a group for loading a family. I think at the time when I set this up for a user, that desk wasn't loaded into their project, or actually it was like 20 projects that they planned on doing this to. It wasn't loaded in, so they could just add this little group and they would automatically load it into all 20 projects when it runs against it. We have a system that automatically runs scripts against projects, so that that way they don't have to go into each one and load the family. So that's what that does. We're going to ignore that and assume that you already have the family in there, and that the family itself that we're going to use in this is something that's in the OneDrive link. So you can try all of this yourself. So is the Revit file. So we're going to grab the rooms. So here we're just grabbing the rooms. Because the rooms themselves are going to leverage for a variety of things. We're going to get the perimeter of the room. We're going to get the base surface of that space, so that we can project points onto it and other things. So that's essentially what we're doing here. We're getting the rooms. We're filtering those rooms by department. And for this example, we're using core classroom. I do have I think it is 5 or 6 core classrooms. The rest are being filtered out. And then we're going to create surfaces for the points to project onto. So those points that what we're going to do is take and we'll look up here, there's a group of nodes, but we're going to pretty much, each room is going to have an origin point that pertains to that room. We're going to create a grid of points, and then we're going to project those points onto the surface, and then remove the points that aren't hitting the surface, leaving us the only points that we care about, which is the ones within the surface that are 6 feet apart. So this is just grabbing the core boundary so that we can create a surface from it, and then also create the walls, which we're going to use to identify when a desk is too close to a wall. It's inside of a wall, and we don't want to place a desk there. So it's doing 2 things. The next one is so I mentioned this, we're going to get a start point for each room. So that's like the origin point, you could call it, for the room itself, which is used for the rest of the points. So it's the first point, and here we're actually giving a offset to that point so that it doesn't sit directly in the corner, so it doesn't place like the desk exactly in that corner, the starting point, because that would be the starting point. You want it offsetted from the wall because that's where the person is going to sit. So you want to account for desk, and the person, and kind of the amount of room that you need. So that's kind of what that's for. So it just offsets that first point. The next bit is to create all the points. So all this does is it creates a grid. This creates each point 6 feet apart, so it just creates a big grid. And then we leverage, you can see here, those points that we got in the previous group. We leverage those coordinate systems to create the points at each one. And what's cool is by keeping it the list organized by spaces. So there's 5 spaces we care about, and there's 5 spaces we care about, 5 lists of points. and we only want to project, the points that pertain to the specific surface. So that's why we're creating like a grid of points per each surface, and not just one huge grid of points. Plus, if you did create a huge grid of points, the points wouldn't align very well. So I found that this, for at least this exercise and with my skill set, I guess, I felt like this was a good approach to handle this. So I kind of mentioned this, but again, this is getting the list of points. We're going to project those points onto the surface, but the points, since we're using lists and we're making sure that those lists stay organized, we're going to project onto the we're only going to take the points that we that pertain to like room A, and project those points only onto room A, so that any other points that fall outside of that can be dropped, but also they don't get picked up by other surfaces from other rooms. So list management and the way that you are leveraging lists are pretty important in this script for that reason. And that way, you're just not you're not placing desks at a whole bunch of random spots, because it's saying, okay, in room B, you've got all these points. These points happen to be from room A, but they're projecting onto that surface. So to avoid that, leverage the list and just project onto the surface that those points are applicable to, which is, like list 0 pertains to, like room A. So that's pretty much what we're doing here. We're just taking the grid per that room and projecting it onto that space. Because what it does is it creates a rectangle grid, and then we want to project that and then trim away any of the points that don't fall onto that that grid, or onto that surface. We want to drop all those points. The next bit is to actually create the desk geometry. So we're not actually placing the families, but we're creating the geometry so that we can figure out if it clashes against walls. The next bit is actually clashing it, but this creates the cuboids that we will use. And so I just accounted for like the width and height. You could probably get creative with this, so that you can read in the width and all the information from the family, so that regardless on what desk family you leverage, it automatically knows the width, length, and height. But for this example, I simply just put in some values. But it creates some cuboids that we'll use to clash against the walls to figure out which ones are too close to the wall. And that's this part here. So we're looking at clashes desk cuboids against walls. So it just takes those cuboids, clashes them against the walls. And this was actually a fun part of the script. So like I said, I built this about 5 months ago, and I briefly looked at it again last night. And it's been 4 or 5 months ago, and I wouldn't say I'm an expert at Dynamo now, but I definitely wasn't 6 months ago. And I was able to look at this script in a few places and try to optimize it, because by looking at this, I think I was originally taking each cuboid and clashing it against every single list or every single wall. So I was like, all right, well, I've already got the list of cuboids kind of organized. So, like if we only have 5 rooms, then those cuboids are usually, they're organized in list, and the cuboids, would be all the cuboids in list 0 pertain to room A. And then, so what I can do, since the walls are organized in that way too, there's only 5 lists of walls, then I can look at the first list of walls and then clash only the points from room A against that first list, which is, list 0 that only pertains to room A. I can clash the points that pertain to room A to only the walls that pertain to room A. Again, it's that list management stuff that I think is really important, and that's why I'm leveraging a lot of levels here. You can see that's set to level 2. It's set to shortest lacing, and then this is level 2, level 3, and then this is using level 2, and then it's keeping the structure of the list. So there's a lot of that going on because it was important to just clash against, instead of taking, like one cuboid and clashing against every piece of geometry or every single wall, when I could, trim that down and reduce how much computation has to happen for it to actually give me what I need. So that was kind of fun, going back and figuring that stuff out. I think that's really important, just, to see what you've done before and try to optimize it. I think you learn a lot by doing that. And I would love also for anybody out there that wants to take this script and make it even better, build upon it, do whatever you want. I think that would be really awesome. So that's kind of it. At the end of this gives you your points. This trims away pretty much, the geometry does intersect, trims away all of the elements that are clashing in the wall. And then we only are left with the list of points that are required for that space, and then we just use those points to place the family. That's what this last bit is for. So oops. So let's go back in there. So that's what I got. Let me know if you have any questions. Again, that information, you'll find it in the description. There is a OneDrive link, and there's folders for every video, or almost every video I've done. You will find a folder for this video where you can go grab that link or that script, the families, or actually one family, and then the Revit file, and you can immediately try this yourself. Also, check out the Discord server. This is where I go, I typically have the Discord server up all the time. I try to post to it often as I can. Feel free to join if you want to start a discussion. It's primarily focused around BIM and data science. So keep your questions and conversations kind of around that if you don't mind. But, anybody's welcome to join this. I've got a number of channels available that you can discuss different topics in. I can add to those channels, but feel free to join it. The link is right here. You'll also find the link below in the description. But I appreciate you watching. Hopefully this was helpful for you. Hopefully you learned something, but I'll see you in the next one. Thanks, everybody.